A very warm welcome to everyone on the global vector control community. Welcome to this particular module of our Asia Pacific Malaria uh, Elimination Network online vector control course, the APMEN online vector control course. This particular module will be on equipment for indoor residual spraying for vector control. And we have the great privilege to have with us Dr. Rajendra Bhatt, who's a retired grade F scientist at the National Institute of Malaria Research at the Indian Council of Medical Research. So Dr. Bhatt has many years of experience, in-depth experience in vector control and in specific this particular topic. So Dr. Bhatt, we thank you for spending time preparing this particular module, and we look forward to learning from you. So without further ado, I'd like to hand over to you. Thank you for your time, Dr. Bhatt.
Thank you, and good morning to everyone who has joined this meeting. And it's a great privilege for me also to be part of this module. And uh, I will start my presentation. This is the typical. The topic is on equipment for indoor residual spraying for vector control. So this is a brief presentation. I have at the end of the presentation given some resources, link to the resources where one can have great details about it. And many of the aspects of indoor residual spraying for vector control have not been covered, particularly the spraying part and the PPE part and the handling of the insecticide, etc., formulations, etc. Those have not been included because otherwise it would have become a too lengthy a presentation. And so I will be very brief, introducing the equipment used for vector control, particularly for malaria and leishmaniasis vectors. So when we start, when we the indoor residual spraying of insecticides operation started way back uh, in the 1940s, and this is a slide taken from the internet. One can see there used to be a knapsack sprayer instead of today's equipment used. And the picture depicts lot many lacunae in the initial the stages of the IRS program. One can see the sprayman smoking. There is a girl child sitting on the cot, and the person is not having any personal protective equipment. So we have come a long way from this, and now we have equipments which are very safe to use for both the uh, spraymen and the public. We in India, particularly, I will talk like to emphasize on Indian vector control scenario. Traditionally, we have been using a different pump which is not recommended by WHO. So we are using the stirrup pump in Indian malaria control program, and of course for Kala Azar program, some donor agencies have donated the WHO recommended compression sprayer. On the right side of the slide, you can see a person using a compression sprayer. On the left side, two persons are using stirrup pump. One is a sprayman who is inside the house. There is a long hose connecting to the stirrup pump, and another person who is generally outside the room, which is not being sprayed, is handling or priming the pump. There is an insecticide inside the open bucket, and one can obviously see that there are great disadvantages of using this technique. First of all, it uses uh, double manpower. There are always risk of spillage of insecticide. handling of insecticide, etc. Uh, on the contrary, the compression spray are comparatively safer to use because the insecticide is inside the tank, and uh, there are very less chances of spillage because of that. Now, when we see the diagram, this is just a brief diagram, application equipment, the comparison of stirrup pump and compression sprayer. Uh, the biggest disadvantage of using stirrup pump is that there is no pressure regulation when we spray on the walls. Uh, and depends upon the skill of the sprayman, how they prime the pump, how they spray uh, on the surfaces. On the contrary, a compression sprayer, we have to fill up we have to prime the pump to a certain level, and then the one person who is using the pump can spray on the walls. And there is a uh, now technology available which we can spray at a constant pressure. So these are the latest equipment, though not latest, but Hudson or any other compression spray have been in use in the program since the last uh, many years. And this one on the right side is a latest introduction to the this equipment. It is a Whisper uh, IK pump. Now, these are the representative pictures and mainly intended for information purpose only, and it's in no way any advertisement or recommendations from our side. But these are the latest equipments used. We will come in detail about the technicalities of this pump. And there is a system of certifying this equipment, because any company which produces or manufactures this equipment has to uh, go through a vigorous uh, testing at the International Pesticide Application Research Center, which is a WHO collaborating center for testing pesticide application equipment. And each equipment goes through a very rigorous testing, different testing procedures. Then it is issued a certificate of compliance by this uh, for the WHOCC. And now, after that, it can be uh, used in the program. So there are many such manufacturers. I just showed you two of the pumps. Now, besides the uh, actual equipments, there are some additional parts which are attached to the pump for a constant flow valves, for example, or a control flow valve, as we call it. They are attached to the lance. Uh, this is a spray lance. You can see spray lance. Here it is, spray lance. So this CFV, or the control or the constant flow valves, are attached to the spray lance. So a constant flow of constant pressure is maintained at the end of the nozzle, and for smooth and even spray. There are four types of valves: yellow, red, blue, and green. They are of different measurements: 1 bar to 1.5 bar, 2 bar, and 3 bar. In malaria control or the vector control program for public health, we are using 1.5 bar, that is 21.7 pound pressure per square inch. That is being used uh, for the public health vector control program. Now, what are the advantages of control flow valve or CFV? During IRS, we want the flow rate of the suspension, insecticide suspension, it is being sprayed on the walls to be constant. So there is no up and down in the discharge rate. Discharge rate has to be maintained at a constant level. And if there is no CFV, the pressure decreases over the time until it is pumped again. So if we don't use CFV, then pressure will go down. And again, we have to prime the pump so that pressure is maintained and again it goes down to a certain level. But if you use CFV, you can see the blue dotted line here on the graph. Uh, that helps us to maintain a constant pressure of spraying insecticide suspension, and just that is advantageous because it decrease in flow rate and ensures an even discharge as tank pressure drops from 4 bar to 1.5 bar. It is recommended that flow regulators 1.5 CFP, that is red CFP, are included in the nozzle top in uh, our IRS program. So by using a control flow valve, the operator has a constant pressure at the nozzle that ensures the output remains the same during an application and also ensures that the droplet spectrum does not change. And regardless of the amount of pressure pumped into the sprayer, the valve maintains a maximum pressure and steady flow at the nozzle. When pressure in the tank falls below the amount set by the valve, that is 1.5 bar, uh, the spray immediately shuts off. So as soon as the pressure in the tank goes down, uh, the valve automatically shuts off the output from the nozzle, and this helps us in accurate spraying, accurate application of dosage, and also it saves water. So here is a comparison of using CFV and no CFV. Uh, the red bars are showing that when we don't use CFV, the output, that is milliliter per minute from another type of compression sprayer, goes down constantly. And in case we use CFV, that is greenish bars, the constant output is maintained. Now, without CFE, when we don't use CFE, we have 8-liter fill. Generally, these pumps are available in different capacities. So we, in the control vector control program, use 10 or 11-liter pump. We fill up the pump with 8 liter of water plus suspension or insecticide. Then, when we don't use CFE, the output will be 50 milliliter per square meter, and it will be able, and we will be able to spray about 200 meters square of area. In case of CFE, 7.5 liter of water will be required. The dosage will be 30 milliliter per square meter, and we will be able to spray about 250 meters square of area. And now comparison of discharge rate and PSI pressure with and without CFE. So dark blue bars are PSI pressure per square inch with CFE, and the red line shows discharge rate with CFE. One can see that discharge rate is constant when we use a CFE, and though the pressure goes down, the discharge rate has remained the same. So it will last up almost 9 to 10 minutes. So once the pressure goes down below that level, that is 21 psi, 1.5 bar, the CFE will automatically shut off the output from the pump. But in case we don't use the CFE, you can see that the discharge rate is going down, and the also discharge rate is going down, and also the pressure is also falling, but there is no stoppage. uh, when we don't use CFE. So there will be a varying amount of insecticide being put on the wall when we don't use CFE, and it will uh, affect the uh, efficacy of the insecticide and the vector control intervention. Now, when we have seen the pumps, we have seen the CFE. Now we come to the nozzle. That is another a very important aspect of the spraying operations. In vector program, when we use any type of pump, either it is a stirrup pump or it is a compression sprayer, we use flat fan nozzle of stainless steel make, or nowadays it is uh, another type of is available. I'm just recollecting. Uh, Ceramic nozzle, sorry, it is ceramic nozzle. So ceramic nozzle, when we use, you can see the small four pictures. Ceramic nozzle, when we use, uh, there is very little wear and tear with the ceramic nozzle. Before and after 50 hours of use, you can see there is hardly any change in the dimension of the orifice in the nozzle. Uh, but when we use stainless steel nozzle, over the use of it, there is a uh, great damage to the nozzle, and this leads to inaccurate amount of spraying. So it is better to either, if you have no access to ceramic nozzle, better to change this nozzle as the spraying operation goes on. That we can do by measuring discharge rate almost every day or every alternate day, so that we come to know that there is a change in the discharge rate because of the damage to the nozzle. And there are many reasons to the causes which causes the damage to the nozzle, and poor handling is one of the most important reason that damages the nozzle. So again, we come to different types of nozzle: solid stream, flat fan, hollow cone, solid cone, and we use flat fan even nozzles. That is the second picture, which gives a spray angle of 80 degree, and gives even spray on the walls. Other types of nozzles are used for other applications, maybe in agriculture or for larvicidal application in vector control programs. But for IRS programs, we use flat fan even nozzles. Now, coming to further the uh, nozzle type, we use flat fan nozzle 8002E. This is the WHO recommended nozzle. Many manufacturers are there in the market who manufacture this type of nozzle. We can see one picture, that is a ceramic nozzle at 002 VK. This nozzle gives 80 degree swath on the walls when the distance of the nozzle is kept at 45 centimeter away from the spraying surface, and the liquid output is 0.2 US gallons, that is about 757 milliliter per minute at 3 bar pressure. But we are using 1.5 bar pressure, so it will give an output of 550 ml plus minus 10 ml uh, and even spray. So what 8002 means is first two digits is meant for gives an indication of degree of spray, that is 80 degree of swath, that is 8 degree. 02 is the US gallon, that is 757 ml, and E stands for even spray. So this is the decoding of 8002E, and this is recommended for IRS programming vector control. Nozzle discharge pattern, the nozzle has been kept about 45 centimeter away from the spraying wall. Uh, when we spray at this recommended distance, it will give a swath of 75 centimeter, making an angle of 8 degree. And when we actually spray in program, we give an overlap of about 5 centimeter. So there is no gap in between the two swaths. So they recommend that a overlapping of 5 centimeter is being done. There are some calculations how we calculate different discharge rate, etc. A spray deposit with compression sprayer, spray deposit with uh, syrup pump. This is how we calculate. And in the training program, we ask the trainers to do certain practical exercises with the actual sprayers and ask them to measure discharge rate. So it's with using 8002 E nozzle and CFV on the recommended WHO recommended compression sprayers. So it should not vary more than the 550 plus minus 10 milliliter per minute at 58 psi and with 1.5 bar red CFV. So 1 bar means 14.5 pressure pound pressure per square inch. Therefore, 1.5 bar is equal to 21.75. So when we use red nozzle, 1.5 bar nozzle, when the pressure goes down in the pump below 21.75 psi, the uh, CFV will automatically stop uh, getting means it will stop functioning and there won't be any output from the nozzle. And one has to be very careful while actually spraying on the walls that sprayman should cover at least 2 meter in 5 seconds. That is 1 meter in 2.5 seconds, so that the speed of 24 minute per meter per minute is achieved. And we calculate discharge rate. Discharge rate is the volume of suspension, that is 550 with CFV in compression sprayers, and swath width is 0.75 meter, and the operator speed as calculated above is 24 meter per minute. So that will give an output of 30 milliliter per meter square. And in case we use the stirrup pumps, the discharge rate will be 40 milliliter per meter square. The correct spray swath, the pump tank to pressure at 4 bar, that is 50, actually 58, it should be 4 bar or 55 psi with CFE, and distance has from the nozzle has to be kept at 45 centimeter from the wall. And if these two criteria are maintained, then there will be a spray swath of 75 centimeter with 5 centimeter overlap. This is how the training board is prepared while we train the actually spraymen or the supervisors. Um, we mark the area on the wall. Uh, there will be a slide after this. 3 meter by 6.35 meter, and the area first line drawn at 75 centimeter, and next swaths are drawn at the distance of 70 centimeter each. And the sprayman has to, these are the actual pictures of training wall. It has been taken from a presentation by WHO consultant in Morocco, sorry, in Nepal. The trainer marks an area of 2 meter high or 3 meter high and 6.35 meters long, divided into 9 bands. The first one is 75 centimeter wide, remainder are 70 centimeter wide. Each swath of 2 meter in height should be covered in about 5 seconds. Key things to practice are timing and distance to wall. One has to be able to maintain a 45 centimeter distance from the wall, and maintain a particular or accurate timing. So how the persons are trained, you can see there is a these persons are all are using this compression sprayer, having a very good PPE kit, and there is the lance. You can see there are sticks attached to the lance. We call it guiding pole or whatever you can call it. So the just it is 45 centimeter from the wall. So when they practice the actual spraying operations, they are uh, able to maintain a distance of 45 centimeter from the wall. So a stick of 45 centimeter from nozzle tip to just touch the wall is attached with the lance, so that they can practice accurately uh, uh, of accurately the spraying, how actually the spraying is being done. Another important aspect is to calculate the exact quantity of insecticide which is required for spraying operations. One can prepare an Excel sheet. Here an example is given for the insecticide alpha cypermethrin 5% wettable powder. The dosage at which it is applied is 0.25 gram per meter square on the walls. You can insert formulae in the Excel sheet. So you have to just put in some figures, and it will give you automatically the amount of insecticide you require for spraying. So A, B, C, D, E, G, up to G is it's given. Dose of insecticide, active ingredient to be applied on walls. We have put the figure 0.25, 0.025 gram per meter square. Percentage of insecticide, that is 5% WP we are using. Amount of water which is required in the filling up of the sprayer tank, that is 7.5 liter. And amount of liquid suspension applied on the wall per meter square using a CFE is 30 milliliter per meter square. And surface to be treated is 250 square meter when we use CFE. And quantity of insecticide required, active ingredient required, there is a given APE, that is it will come in gram, that is 6.25. And quantity of formulation needed for selected tank load to cover the area given in row E, that is 250 meter square, that will come to 125. So any insecticide you use, any new formulation comes to you, you use this almost a ready reckoner. One can calculate the actual amount of insecticide required for one tank load of uh, the sprayer. There are some additional WHO resources available online. One can always refer to these resources for more detail, because the presentation is very brief and it is only aimed at uh, familiarizing the trainees to the equipments and the other paraphernalia used for the accurate and good quality of spraying. Because there are many technicalities which I do not want to dwell into. Otherwise, it would be very lengthy presentation. But these are the additional WHO resources: indoor residual spraying, then a manual for indoor residual spraying. It is under revision, but still available. All versions is all version is available on the net, and equipment for vector control, and there are some specification guidelines given. Another very useful resource is an animated video CD on IRS. I couldn't find the link on the WHO website, but I have given a YouTube link by Iran Borja. One can see a 30-minute video and a very detailed video uh, covering almost each and every aspect of the IRS operation, what precautions should be taken, how to handle the pump, how to handle the leakage or the choking of the uh, nozzle, safety precautions, disposal, and other aspects of IRS program. So this is a very useful resource, online resource available. There is a publication about comparing the spray quality of stirrup pumps with the compression pump by colleagues in Indian Council of Medical Research. Uh, this is also available online, and the conclusion is that the compression pump was found to be more user-friendly due to slower weight, easier to operate, lower operation cost, higher safety, and better efficiency in terms of discharge rate and higher area coverage than the stirrup pump. So it is obvious that there are many safety aspects attached to the IRS program. One of the most important one is the exposure of the sprayman to the insecticide. So this compression pump reduces it to the maximum level, and that is why it is more user friendly, is safe to use. That is all. I think I have been able to do some justice to the topic assigned to me, and over to you.
Dr. Bart, you certainly have done justice to the topic that we asked for your support. It is precisely the background theory and practical understanding that our entomologists in the National Malaria Control Programs and other vector-borne disease control agencies require to understand and effectively apply at least IRS. So for the very valuable and in-depth experience and understanding you've shared with us, we know it will be of great benefit to our vector control communities, especially the young and aspiring and upcoming new entomologists. And we thank you sincerely for your inputs. Thank you, Dr. Bart.
Thank, thank you very much. It was my pleasure.
Dr. Bhatia, I think we've stopped recording now. So again, from my side, I apologize for the glitches this morning.